Hello everyone, thanks for coming. And today I'm going to do a brief review of what we have learned in the second half of the quarter. So the first chapter we learned is the swarms. The core thing here is the comparative advantage statement. So the comparative advantage means that two companies have comparative advantage involving fixed and floating rates, and they decide to swap their interest rate. So the question here is how to calculate the interest discount. Sometimes we also have a bank as an intermediary, and then the bank is going to take a spread. And under that case, how to calculate the interest discount? That is a core question of this chapter. The second thing is the evaluation of swaps. So it's principal times time times the interest rate difference times E2 minus RT. E2 minus RT is the discount rate. The second thing we have learned is the option pricing. So how do we evaluate the intrinsic value of options? First, we have the put call parity for the European option. So this is the call option plus the cash equals to the put option plus the stock price. For this put call parity, we can derive the lower bounds for the call option as well as the lower bounds for the put option. Because the value of the European option equals to the value of the American option if the stock is dividend paying. So we can also derive the lower bounds for the American call option. The upper bound is just the stock price for the call option. For the put option, the upper bound is the price times the discount factor. For the American options, we don't have the put parity equality hold. Instead, we have an inequality. We can put this on our cheat sheet. So finally, we have the put call parity for dividend paying stock. In a general case, evaluation of options and as well as other financial derivatives involves binomial tree. So binomial tree is how we discretize time. We set the time step to be small and to predict how the stock price will change in the future. The core assumption here is the risk neutral assumption, which means that we don't expect a higher expected return for investing in the stock, then we just put in the money in the bank and earn the risk-free interest rate. So for any financial derivative, the expectation of its current value is the expectation of its future value times the discount. So usually we set the upward movement ratio to be into sigma RT and the downward movement ratio to be into minus sigma RT, where sigma is the volatility and delta T is the constant. Finally, we learned our stochastic process that is necessary for understanding how we determine the price of options. The simple case is a Wiener process. So for Wiener process, you can independent increments and the increments observe the normal distribution times the factor square root of 30. Generalized Wiener process has shifts, which means that the mean of the Wiener process is 0 and the variance could be non-standard, which means that the variance is not 1 anymore. Next, we learn the E2 formula and Black-Scholes model for determining the stochastic differential equation satisfied by the stock price as well as the stochastic differential equation satisfied by the financial derivatives. So for the stock price, that is stochastic differential equation, we have DST equals to mu ST dt plus sigma ST dt, where BT is the standard Wiener process. So we can write the stochastic differential equation for general financial derivative. Next, for evaluating the stochastic for the differential equation satisfied by the option, we have the back choice model. So note here that the right hand side f minus s partial f partial f. This is a risk-free portfolio. So we are always expecting to earn the risk-free interest rate R from this risk-free portfolio. And the left-hand side is the increment of this portfolio with respect to delta t. Finally, we have the option pricing formula for determining the European call option and European put option pricing. It's no non-dividend paying. So the formula is kind of complicated, and you can put this on your cheat sheet if you like. That's all what we have learned in the second half of the quarter, and thanks a lot for attending my discussions and watching this video. Thank you.